Okay, so I'm going to go quick through this, assuming that you've already thought about it or tried it. The first one up here at the top says, write a possible equation for the following graph. So let me zoom in on this. All right, so for something like this, the key part is to notice your zeros, because whatever your zeros are, or your x-intercepts, that is going to be, whoa, mystery numbers popping up. That is going to be your factors. So for instance, since it crosses at -2, I'm going to start by saying x plus 2, and since it crosses at x minus 2, I'm sorry, at +2, that means this factor is x minus 2. It crosses at +4, which means it came from a factor of x minus 4. Now, I need to check two other things before I quit. I need to check whether I cross through the axis or whether I bounce. If I cross through, the multiplicity is 1, which means the exponent is 1. But if I bounce off the axis, it means it had a multiplicity of 2. So I'm just going to stick that squared on that exponent. I think I put it on the wrong place. Sorry. The squared needs to go with the x plus 2. Sorry, squared. There we go. So wherever you bounce is where you get the exponent. Now the other thing is end behavior. Since this is going down on both ends, I'm also going to insert a negative at the front. All right, so that's a little, that would be more of a bonus challenge pre-AP type question if it's on there. Okay, the next set, these are great. For each problem, it's going to have you do all of this stuff: degree, end behavior, zeros, multiplicity. So you start with degree, which would be your highest exponent. So this one has a degree of 3. And then as far as the end behavior, you're going to analyze this term, and since it's an odd exponent, and it's positive in the front, I know that it's going to be going down on the left and it's going to go up on the right. So you might use words like falls left, rises to the right, something like that. As far as the zeros go, zeros are where you have to set this to 0, guys, and solve. You have to find the x-intercepts. So sometimes it's factoring, and sometimes it's not. Now this one looks like it'll factor, because I know I can take an x out of all the terms. And then I'm going to try factoring it down again. So, let's think. Two numbers that multiply to 8, but add up to -6. I think that's right, except that's a 2. There we go. All right, so if this is what it factors into, then I take each factor, I set it equal to 0, and I have my solutions. So the zeros of this polynomial are going to be 0, 0 from the first one, +4, 0, and +2, 0. Notice I wrote them as coordinates because they are x-intercepts, okay? So I've taken care of all that. Oh, and the multiplicity of each. Multiplicity just means how many times was it your answer. So when we look, these only showed up one time as an answer, so the multiplicity of each one is 1. So I'm just going to, all of them have a multiplicity of 1. If one of the numbers or factors had been the same as the other, then it might have a multiplicity of 2. Okay, so that's it. That is, we know what the graph's going to go through. We know that it's going to go down on the left, up on the right, and we know that it crosses through the axis every time. So there's number 1. Now, number 2, it's a little different. And there's going to be a little different on this one, guys, because I can already tell that I can't factor that. Like when I look at that, there's nothing that I can take out, and so it becomes a little scary. It'll still be a degree of 3. And the end behavior will be the same as the last one. But when I get to the part of setting it to 0, I can't factor. And when that happens, you have to resort to long division, or synthetic division. I'm going to use synthetic division. So I'm going to copy my coefficients, 1, -3, 0, and 4. Now why did I put a 0 there? Well, this is missing a 0x. You need to make sure all exponents are accounted for. And it was missing x to the first, so I fill in a 0. Now, I don't have a number out here. Sometimes on the test, they might tell you the number to use. They might say, like, show that 1 is a solution, and if they say that, you just put the number 1 out there and then you go. But if they don't, you have to know to try your own numbers. using possible rational zeros. And you get those by doing all the factors of what's in the back divided by all the factors of what's in the front. So possible answers to this problem, possible roots, are plus or minus 1, 2, and 4, because those are numbers that go into the number in the back. And as far as the 1 in the front, that really doesn't matter, because you're supposed to take all of these and divide them by the number in the front, but you know, all of these over 1, they're just the same. So one of these numbers will hopefully work, and what that means by work is I'm going to try a 1 in the front first just to see, and I'm going to do synthetic division. So drop the first one, multiply, add, multiply, add, multiply, add. This does not work. You're trying to get a 0 back here. So since that didn't work, I'm going to try again, and I'm going to try with a new number. So let me try 2. I'm going to drop the first one, multiply, add, multiply, add, multiply, add. Yay. So that was awesome. That worked. So since I got a 0 back here in the back, that tells me that 2 is in fact one of my solutions. Now to find my other 2 solutions, remember you take your leftovers here and you try to factor that down as well. And when I factor that down, it looks like I'm getting a -2, +1 inside the factors, which means that my zeros for this problem are the 2 that I found initially right here. This one's going to yield a 2 again, and then this one's going to yield a -1. So these are my solutions. What you could write for multiplicity is the multiplicity of this one is 1, and the multiplicity of this is 2, because it showed up twice. And so that is that. The next type of problems are going to be rational functions. Man, I have all kinds of old math on here. Sorry about that, guys. Ignore all of that. Okay, so now we're going to be finding the critical intercepts and asymptotes, and we're going to graph it. So the first thing I always do on a rational function is I try to, I'm going to shrink this down because I'm going to need a lot of room. I'm going to try to factor and cancel. So like for that first one, the first thing that I would do is factor it down. Let's see, -4 -1. Yeah, I think that works. I would do this first because whatever cancels out is going to tell you what your whole is. So I know there's a whole at 4. And the way to get the y that goes with that is to take your leftovers, your remaining polynomial, your remaining equation. This is your new problem, okay? And we're going to take the 4 and plug it in here. So I'm getting 8/3. Okay, so I have a whole at 8/3. Now as far as finding the rest of this stuff, I'm just going to talk you through the order that I do it in. I always set the top to 0 first, and when I set the top to 0, that's going to find me my x-intercept. Then I set the bottom to 0, and when I do the bottom to 0, that's going to find me my vertical asymptote. That also is going to tell me my domain. Because now, guys, your domain is going to be all real numbers, except x cannot equal the vertical asymptote. It can also not equal where the whole is at. So notice I included the 4 and the 1. If this doesn't look familiar for writing domain, your teacher may do it like this: -∞ to 1, 1 to 4, 4 to infinity. One of those two should hopefully look familiar. And now the only thing left to find is the y-intercept and the horizontal asymptote. So for y-intercept, you plug in 0 for all of your x's. So it's going to be 0 + 4 over 0 - 1. So it's going to be the point 0, -4. Remember, I'm writing things that I'm showing you here how things are supposed to be written. So are they supposed to be a point? Are they supposed to be an equation? And this is what you need to model after. Now the horizontal asymptote, this is the hard one. This is the one where you compare your exponents. And 3 things are going to happen. It's either bigger on top, bigger on bottom, or they match. In this case, they match. They both have an exponent of 1, so I just take the coefficients. So y = 1 is my answer. I'm going to shut up right now and do a very quick sketch of everything that I just did here, just so you can see what it should look like. Okay, y-intercept at 1, vertical asymptote at 1, whole at 4 and 8/3, x-intercept at -4, and a y-intercept at 0, -4. So once I get all that together, I'm just going to play connect the dots. Remember, most of these graphs kind of look the same, and you're done. So, and it may go in a little more. I don't know about the steepness of this, but I'm just guessing. All right, so that's kind of what it looks like. All right, so same exact thing, but number 2. So it's 2x minus 1 over, what is that, x squared plus 3? All right. La 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 la. Okay, so 2x minus 1 over, okay, so the first thing I would try is to factor and cancel, but looking at this, nothing factors and cancels, so that means there is no whole. I'm going to put a NA, there's no whole. So I'm going to start like I did on the last one, set the top to 0, and when I do that, I'm going to get a 1/2, and that's going to find me my x-intercept. Oops, I wrote it backwards. It should be 1/2 comma 0. Then I'm going to set the bottom to 0. And when I do that, what am I finding? Well, I'm finding my vertical asymptote. So when I set the bottom to 0 and I try to take the square root of both sides, this should be scary for you because that is not allowed. So since that's not allowed, that means there is no vertical asymptote. Okay, and that happens sometimes. It's okay. Now let me find my y-intercept. So for y-intercept, I plug in 0 for the x's. And when I do that, I'm getting a -1 over 3. So I'm going to write that as a coordinate. So far, this is pretty much all I know. There weren't any holes. There weren't any vertical asymptotes. I only know my intercepts. And the last thing to check for is the horizontal asymptote. And when we do that, we compare powers. Now this one is bigger on the bottom, and if it's bigger on the bottom, meaning the exponent, not the coefficient, if the exponent's bigger on the bottom, it's always 0. So this is what I know. I've got a vertical, a horizontal asymptote at 0, but I'm going to cross at 1/2, 0, and I'm going to cross at 0, -1/3, and this is what I know. Now, I don't know a lot, so if I was like supposed to make a graph out of this, my gut tells me it's going to look like this, and then at some point it's just going to come back up. But if you're scared and you're like, oh my gosh, I don't know what this is going to do, you can totally pick a number over here. Like, let's pick x as -1. We can take x as -1 and plug it into our function for all of the x's and get the y. So if I do the math on this, I'm getting -3 over 4. So at -1, this is supposed to be at -3/4. So I actually did a really good guess of the graph, but feel free to pick a few points on either side and plug them in if you get scared, but it's probably going to look something like that. Okay, number 3, list the transformations for -1 over x plus 2 minus 3. Okay, so basically you're just supposed to know that this is modeled after the parent function 1 over x, and some different stuff has been done. So there's a negative in the front, which tells me that there's a vertical reflection. The x has a plus 2 with it, which means it's probably going to move left 2. And there's a -3 on the outside of the function, which tells me it's moving down 3. So done with that. That's all you got to do. And then the last one, expand. So this is a binomial expansion. 2x minus 3y to the 5th. These are fun, right? Haha. Okay. There's all different ways to do them. I'm going to show you what I believe is the fastest way. If there's a 5 there, I'm going to draw 6 blanks, because that's just how they work. It's always one more down here than your power. Now, I take my first term, and this is the term that I count down with the exponents. So I'm going to write 2x to the 5th. In this blank, 2x to the 4th. Notice my use of parentheses, because you do not want to forget that that 2 is also getting a power. And I could write 2x to the 0, but anything to the 0 is 1, so I'm not going to write that. All right, then with the thing in the back, so the 3y, notice there's a negative on it. So negative 3y, now the exponents are going to count up with that one. So this is negative 3y to the 0, not going to write it. This is negative 3y to the first, negative 3y squared, so on and so forth. And I am almost finished. The only thing left to do is there are these magic coefficients. Now, you can either do the NCR stuff, if you remember the NCR stuff, and that will find you every single coefficient, or if you have time to construct Pascal's triangle, that's what I use every time. Pascal's triangle, if you just remember the tree of ones, and if you can get that far, you can get the rest. So you've got these 3 ones at the top, then we start adding the numbers on top. So for this next row, I start with a 1, but then 1 plus 2 is 3, 2 plus 1 is 3, stick another 1 in the back. Let's do it again for the next row. Start with a 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, stick a 1 in the back. And we keep doing this until we get to the correct row. Now, how do you know if you're at the correct row? Well, there are 6 blanks down here. Find me the row that has 6 numbers in it. And there it is. So I'm going to take those numbers, and they are going to be the coefficients for each and every one of these. And now it's just simplifying. 1 times 2x to the 5th, well, you're going to have to do 2 to the 5th and call that 32x to the 5th, okay? Then we're going to have to work this out. So you'll be doing like 5 times 2 to the 4th times negative 3. So this is where I want to quit because I don't have a calculator, and that would be a negative 15 times 16. And then I will have x to the 4th, y to the 1st behind it. So whatever this is, I'm trying to work on it for you guys. It looks like I'm getting 0 for 240. Okay, so I think that's right. Anyways, that's what you would get for that term. And I'm going to stop here for the sake of a long video. But that's what you would do with each and every term, is just simplify it out, and then that would be your expansion. Okay, hopefully that helped. If not, send me a question.